Okay, so I know most of us have probably seen a triangle before, but for this lesson, pretend like you have no idea what a triangle is. And you know nothing about triangles. You don't know the formula for the area of a triangle. You don't know, I don't know, how all the angles add up to 180 degrees. You don't know that yet, but we'll get to it in a little bit. This is our first encounter with a triangle. So, what is a triangle? Well, it's a shape that has 3 angles. That's why it's called a tri-3-angle. So to form one, you connect 3 line segments together by each of the endpoints. So each point on the not each point, but the corner points are called the vertices of the triangle, and we name triangles by their vertices. So this triangle could be called triangle ABC. It could be called triangle BAC, CBA. Doesn't matter, as long as you name it with the 3 points on the vertices. And the segments that make up the triangle are called the sides of the triangle. So AB, BC, and AC are all the 3 sides of a triangle. This one in particular. So now that we've, defined a triangle, shown a little bit about it, let's start our first problem. Now, you could probably see that, okay, there's a triangle figure in here, but there's a lot of other stuff going on. And that's because the whole point of this problem is that we're going to build our way towards proving some basic facts about triangles. And in order to do that, we can't really assume much about them. We can only use the tools that we have available so far. And the one tool we have is we know stuff about parallel lines at this point. So if we assume that lines L and M, that'll be like this line is L, here's line M, assume that they're parallel to each other, we want to find the measures of angle BCD and BDC. So we're given some information about the angle measures, like angle CBD is 50 degrees, but we can't assume anything else about the triangle itself. So how can we go about solving this? Well, let's just take a look at the information it gives us. We have this 70-degree angle right here. Well, I know vertical angles are congruent. So if I look at the 70-degree angle, I'll see that this over here is vertical to that 70-degree angle. So this angle has a measure of 70 degrees. Okay, that's one thing we have discovered so far. Okay, well, what else can we do? Well, one of the other big ideas we learned about is that a straight angle, or an angle that, is on a straight line, is equal to 180 degrees. So if I combine this angle, and this angle right here, that would form a straight angle. You can see the semicircle-like shape that angle makes. So that is equal to 180 degrees. So with that, I can find out what the value of this mystery angle is right over here. Because the mystery angle, when added together with the 50-degree angle and the 70-degree angle, must be equal to 180 degrees. Again, because it forms that straight angle. Okay, so let's combine our like terms. 50 and 70, that gets us 120 degrees. Set that equal to 180. So to solve for the mystery angle, let's subtract 120 on both sides. And we find out that the mystery angle is equal to 60 degrees. 180 minus 120. So not so much of a mystery anymore. We now know that that angle is 60 degrees. Okay. So what can I do with this information? Well, the only thing we really haven't done yet is use the fact that L and M are parallel to each other. So how can I use that information to help us out? Whoa. Let's do that. Okay, we'll just leave it. So when we learned about parallel lines, we discovered that there's special angle properties that we can utilize. For example, one of the most commonly used ones is called alternate interior angles. Alternate interior angles on parallel lines, they're equal to each other. So if I look at the interior of these two parallel lines, L and M, interior meaning the inside portion here, and look at, like, let's say the 70-degree angle. Let's take a look at that one. So that's on the interior. And alternate is referring to the transversal. So alternating sides of the 70-degree angle would be over here. That's alternate interior with the 70-degree angle. And like I just said, alternate interior angles are, in fact, equal to each other. So I can say that this is a 70-degree angle. Similarly, let's see. If I look at the 60-degree angle, well, that angle is alternate interior with this one right over here. So that means that this angle is also 60 degrees. And that gives us everything we need to complete this problem. We have determined that the measure of angle BCD is equal to 60 degrees. And that the measure of angle BDC is equal to 70 degrees. That is it. Now, what's significant about this problem? Well, you may have noticed that if we're looking at the triangle BDC, all three of those angles happen to add up to 180 degrees. And that's the result of these parallel line properties that we used. So that's interesting. They add up to 180, kind of just like a straight angle does. I wonder if that always holds true. Well, that's what we're going to discover in the next problem. We're going to prove that no matter what the measure of the angles of a triangle are, that they will have to add up to 180 degrees. So stay tuned for the next video.